Hello everyone, welcome to Josh Max channel. In this video, we are going to see for CBSE Maths Grade 12 Standard Chapter 5 Continuity and Differentiability in Exercise 5.2 10th sum. Okay, so prove that the greatest integer function defined by f of x equal to greater integer of x, and here condition of x is given, is not differentiable at x equal to 1 and x equal to 2. So the given function, that is greater integer function, is not differentiable at x equal to 1 and at x equal to 2 we have to prove it. And for proving any function, if it is not differentiable, okay, if it is not differentiable, we have to say left hand derivative and right hand derivative are not equal. Okay, if left hand derivative, right hand derivative, if it is equal, then that particular given function, that is f of x, is differentiable. In case if left hand derivative, right hand derivatives is not equal, then given function is not differentiable. Okay, and here left hand derivative formula I have given: f dash of x equal to limit h is approaching to 0, f of x minus h minus f of x by minus h. And right hand derivative is f dash of x equal to limit h is approaching to 0, f of x plus h minus f of x by h. So the given function, first let's find out left hand derivative, right hand derivative. Then in place of x as a 1 and 2, let's replace it. Okay, so given function is f of x. I'm going to find out left hand derivative first. Okay, that is f dash of x. The formula is, here we have limit x is approaching to 0, f of x minus h minus f of x by minus h. Okay, and here what is the f of x? F of x is a greater integer function. So in place of x, whatever input, that input is becoming as a greater integer of x. Here what is the input? X minus h, no? Then what happens to this? Greater integer of x minus h. So if f of x equal to greater integer of x, then f of x minus h is greater integer of x minus h. And this is given f of x itself, no? Greater integer of x divided by minus h. So this is left hand derivative. Okay. Now same way, right hand derivative, let's find out. Right hand derivative formula, f dash of x equal to limit x is approaching to 0, f of x plus h minus f of x by h. So whatever input we give, it converting in terms of greater integer function, right? Same way here, input is x plus h, then it will convert in terms of greater integer of, sorry, this is h. Okay, so greater integer of x plus h. Then f of x is greater integer of x, then by h. So this f dash of x of left hand derivative, I am going to keep it as a equation 1. This one as a equation 2. So in equation, what they said? Prove that greater integer function defined by the function is given is not differentiable at x equal to 1. First, let's prove for at x equal to 1. Just replacing wherever you see x as a 1. Okay. If x equal to 1, what happened to the left hand derivative? Okay. It is left hand derivative. That is f dash of 1 limit h is approaching to 0, 1 minus h minus 1 by minus h. Okay. Since it's a greater integer function, we know it well. 1 minus h, what is the meaning of that? From the 1, we are just subtracting. So if it is subtract, it is a less than 1. So less than 1, if any value lies between 0 to 1, if it is greater integer of 0, the value is 0. If it is greater integer of 0.5, the value is still 0. If it is 0.9, the value still is going to be 0. Okay. So then 1 minus h. So h is interval differencing. That point value, even if it is reduced, whatever value lies between 0 to 1, the value is 0. Then what is the value of this? 1 minus h gives you 0. So just replacing limit h is approaching to 0. What is the value of that? 0 minus 1 by minus h. Then we are getting limit h is approaching to 0 minus 1 by minus h. Now minus minus sign get cancelled. We have 1 by h. Now limit h is approaching to 0, 1 by h. Is it for further we can do simplification means no. Then let's apply the limit value. If h is approaching to 0, that is 1 by 0, which is undefined. Okay, so left hand derivative result we are getting undefined. Now right hand derivative, let's find out. So equation 2 we have taken, no? So replacing x as a 1 in the equation 2. So right hand derivative, what is the right hand derivative result we got? F dash of 1. So replacing x as a 1, no, f dash of 1. Limit h is approaching to 0. 1 plus h minus 1 by h. Now limit h is approaching to 0. Value of 1 plus h we are going to find out. Okay. So basically 1 plus h means the values which lies between 1 and 2. That is 1.5. Basically 1 plus 0.5 which is 1.5. That's what it means. Okay. So whatever value lies between 1 and 2, the greater integer of 1.9 also which is 1. Then 1 plus h gives you 1. And greater integer of 1 is 1 itself. Okay. So minus 1 by h. 1 minus 1 what it gives? 0. So limit h is approaching to 0. 1 minus 1 0 by h. 0 by h value which is 0. Limit h is approaching to 0. Here 0. There is no variable in terms of h. So for the constant term, if the limit if we apply same constant, then result is 0. So right hand derivative what we got here? 0. Here left hand derivative we got undefined. So we can notice that left hand derivative is not equal to right hand derivative. So what we can conclude from this? We can say that the f of x, that is greater integer function, is not differentiable at x equal to 1. Okay. Now the same way we also going to prove the given f of x is not differentiable at x equal to 2 as well. So just in the equation 1, okay, and in equation 2, in place of x we are going to replace 2. Okay. So let's start now. If x equal to 2. So first left hand derivative, that is f dash of 2. So what we have here, equation 1, just have a look. Limit h is approaching to 0. Then greater integer of x minus h, no? Here x is what? 2. So 2 minus h. Then minus greater integer of x we had. Okay. Then greater integer of 2 by minus h. Let's cross check. So we just replaced x as a 2. So greater integer of x minus h minus greater integer of x minus h. So just replaced x as a 2. Okay. So now I'm going to find the value of 2 minus h. So just understand 1 over here, 2 and 3. 2 minus h, what is the meaning? That means 2 minus h values lies between 1 and 2. Okay. So for any value which lies between 1 and 2, if you take the greater integer of that particular value, it always gives you 1. That is 1.999 also gives you the value 1. 1.5 also gives you 1. So that means what? So whatever value lies between 1 and 2, greater integer value if we take, the value is 1. So 2 minus h, what it gives? It gives you 1. Okay. And greater integer of any integer is what? The same thing, no? So that is 2 itself. Minus h. 1 minus 2. What is the value of 1 minus 2? which is minus 1. Here minus h. Now minus minus cancel. We have only 1 minus h. Sorry, minus minus 1 plus 1 by h. Now applying the limit, what happens? It gives you 1 by 0, which is undefined. So left hand derivative, what we got? 1 by 0 undefined. Now right hand derivative is the same or not, we are going to check. Okay. So right hand derivative, that is what equation 1 we have named, no? So in equation 2, equation 2. So right hand derivative. So in place of x, I am going to replace 2. So f dash of 2 equal to limit h is approaching to 0. Let's have a look on the equation 2. A greater integer of x plus h. So what is x that we have taken as a 2? Then 2 plus h minus greater integer of 2. So greater integer of 2 plus h minus greater integer of 2 by positive h. Okay, now what is the value of 2 plus h? We have to check. So 2 plus h meaning is what? The values which lies between 2 and 3. Basically those are 2 plus h. So any value which lies between 2 and 3, if you take the greater integer of that particular value, what is the value? It's a 2. So 2 plus h gives you 2 only. So limit h is approaching to 0. Greater integer of 2 plus h is 2. Then greater integer of 2 is, that is also 2. Okay. So greater integer of any integer is the same number. And for the decimal values, we have to take the immediate least one. Okay. The least decimal we have to take. So by h. So 2 minus 2, what is the result? 0. 0 by anything is what? Which is 0. Now what is the limit? H is approaching to 0. 0 is a constant. So for the constant, if you apply the limit, same constant only the result. So right hand derivative. Now what we understand from this, here left hand derivative is undefined. Here right hand derivative is 0. So which is not equal. Left hand derivative is not equal to right hand derivative. From this, what we can say? What we can say from this? The f of x, that is greater integer function, is not differentiable. What point we tested here? 2, no? Not differentiable at x equal to 2. Okay. So in a question they are asking us to prove that the greater integer function is not differentiable at x equal to 1 and as well as for x equal to 2. So we proved for both the points. So that's all this sum. Okay. So hence proved. Thank you for watching and please do subscribe. Thank you.